problem, example 4, is going to be the same idea, except for we just have this. It's called a rational function, guys. Rational meaning ratio, meaning it's a big fraction, okay? So if this is f of x, what is f of x plus h? Well, remember, whenever you do that, you just plug x plus h in wherever you see the x. So this is just 2 over x plus h. Is that okay? The next part we're going to do is, now that I'm thinking about it, I really should have prepared you by going over fractions. Because what we're going to do is we're going to combine like terms. What do you need when you add or subtract fractions? You're going to need a common denominator. And that's something that we didn't cover, but we'll get through it, okay? So, dot, dot, dot. We're going to use this up here. I'm not going to rewrite it just because of room, right? We're going to take our f of x plus h function, which is this, 2 over x plus h, and subtract f of x, which is just 2 minus x, and that's all over h. So that looks like all kinds of wrong because you have a fraction minus a fraction in a fraction, right? Doesn't that just look like you don't want to leave it that way, right? So what we're going to do is we're going to clean it up by just focusing on the top first. We're going to just leave like over h, over h, over h as we do this math. So remember, in order to get subtract fractions, you need a common denominator. For example, 3/5 minus 1/4. What's the common denominator between 5 and 4? What number do both 5 and 4 go into? 20, right? Do you guys agree? So it's like if you have like a pie and it's cut into 5 pieces and then like you need it for 20 people, you cut it 4 more, right? So the shortest way I can tell you guys is this needs, the common denominator needs x plus h. The common denominator needs x. They don't have any common factors, so guess what the common denominator is? The product of the two. And I'll do it like right up here. Say we're doing 3/5 minus 1/4. We would need to make it a common denominator of 12, right? Or 20. How do you do that? You say, okay, what times 5? I need a 5 for my denominator. I need a 4 for my denominator. So I'm going to multiply the two and get 20. It gets a little bit more complicated if they shared, like what's the common denominator between 8 and 2? 8, right? Because 2 goes into it. But if they have two denominators that don't share anything, the LCD is just multiplying them. Exactly right. So we just happen to have two very generic denominators, x plus h and x. So what are we going to do? Multiply them. All right, let's use this example up here. How do we convert this to an equivalent fraction? Meaning, if I'm supposed to have 3/5 of a cookie cake, and then all of a sudden you cut those pieces into 20 pieces, don't say I'm only supposed to get 3 of those 20, right? We want to keep that ratio, that proportion the same. So if you remember, whenever you go from one denominator to the next, you just ask yourself, what did I multiply 5 by to get to 20? 4. So what do I need to multiply the top by? 4, right? So the whole idea is to keep that ratio the same. 12/20ths would reduce to 3/5. Do you guys see that? Help me out here. What do we multiply 4 by to get to 20? 5. So what do we need to multiply the top by? 5. So again, if you had to reduce, 5/20ths reduces to 1/4. All right. So you're like, well, how does that help us? Ours is, I think, even easier. He had an x plus h. We have it, but now he has an x. So what do we have to multiply the top by? An x, right? Because who's the new guy, right? Who's the new guy? Do you guys agree that if these x's canceled out, you have your original fraction? Right? And that's the whole idea, is like check yourself by reducing, and it should reduce back to your normal one, okay? And then this guy had an x, but who's new in town? X plus h, right? So we're going to have 2 times x plus h. And again, think about reducing. If you were to reduce this one, what would happen with both of those x plus h's? They would cancel out, and they would leave you with what? 2 over x, your original guy. So now that we have the common denominator, we only have to write it once. So here, we would only have to write it once, right? And we would just say whatever 12 minus 5 is, that's my numerator. So here, we're just going to write it once. But I'm going to write my numerator together. So this is going to be 2x minus, let's distribute the negative here and here. Actually, we're going to distribute a -2, guys. Okay? What'd you say? Negative 2x. Is everyone okay with that? So we have the 2x from the original fraction, but we're going to distribute a -2 to x. So it's going to be a -2x. But then we're going to distribute the -2 to the h. So it's going to be what? -2h. Looks weird, doesn't it? All right, and we can't forget that all of this is over h, and all of this is over h. Oh, that's crazy. I know. I try to space it out as much as possible because I have big handwriting too. All right, we're almost done because what are you noticing about the top numerator? The 2's are going to cancel each other out, so let's write that over here. Negative 2h over x plus h. And I'm going to throw at you guys again another fraction. Whenever you divide by a fraction, it's the same thing as multiplying by the reciprocal. Do you remember that? Whenever you divide by fractions, you change it to a multiplication sign and you flip the second number. I probably need to make a topic going over this. So he's technically over 1, so we're just going to multiply it by 1 over h so that we can kind of get to one fraction. Or another way to think of it, guys, is if you have a fraction over a denominator, that denominator just kind of bumps up and goes with that denominator. So see how we're going to have it all in one row now, right down here? So this is negative 2h over x plus h. So whenever you divide by a single number, you just multiply by the reciprocal there. And what do you notice about the h's?
The h's will cancel out.
And you're left with negative 2 over x times x plus h. And I know it seems weird, but in calculus, what we want that h to do is get smaller and smaller and smaller. We want that gap to get smaller and smaller and smaller. So we want the h to go to 0, right? So if h went to 0 here, that would just be, like I said, my power rule. If h went to 0 here, what would I just have on the bottom? X times x, or x squared. You guys just did calculus. You just found the derivatives for 3 functions: a line, a parabola, and a, what's that one called? Why can't I think of it? Hyperbola. No, it's not a hyperbola. It's an inverse function. And we'll talk about that later.